The laws of logarithms, since logarithms are just another way to express a power or an exponent, are the same as rules for exponents. So with an exponent, if we are, and I want to write some things down here at the bottom, if we have the same base with two different exponents and we're multiplying, then we're going to add. Well, what you can see in the problem, in the multiplication rule, is that we are multiplying, and so that means we're going to add the numbers, what's inside the logarithm. So this is our rule. We're going to separate these, make it log b with an m, and then we're going to add, and log b with the n. So the things that were multiplied on the inside of the logarithm get separated into their own logs and added. So the same thing with division. If we are dividing, then we're going to subtract our exponents. Well, as you can see in the division rule, we are dividing inside our logarithm, so then we will subtract. So log base b m minus log base b n. And then with our power rule, if we have a power to a power, that means we multiply. A times b. Now in here, the log base b m, forget the k for a moment, that is a power itself, and the k is also a power. So then what we're going to do is take this k, we're going to move it to the front and make it a multiplication. So we'll have k times log base b m, and these are the three laws that we're going to be working with today. For our first example, we're going to separate this logarithm into two parts. We have two parts of our number. We have an a and we have b. So what we need to do is first separate those, and we are multiplying inside the parentheses. So that means multiplication and power rules means that we're going to add. So we're going to separate this like so. And then what we see is we have a square root of b, and we're going to change that to an exponent. And an exponent with a square root is actually 1/2. So log base 10 a squared plus log 10 b to the 1/2. And I could have gone ahead and moved the power for the a squared to the front, but I kind of like to do things all at the same time. So we have these two powers here, 1/2 and 2. We're going to move those to the front and multiply. So equals 2 log base 10 a plus 1/2 log base 10 b. And the question that I hear a lot is, how do you know you're finished? The way you know you're done is when you have a single term right here, or a single grouping right there, and no powers, no exponents, then you're finished. Okay, we're going to separate this one again, and what I can see is that I'm dividing, and the rules of exponents is if you divide, you subtract. And so that's what we're going to start with, is we're going to separate this into a subtraction. So log base 10 a to the 5th, and we're going to deal with the powers last. Don't do the powers quite yet. Now that's the square root of b cubed. Now if you remember, we're going to change that also to an exponent, and it's going to be a fraction exponent. So I'm not going to do anything to my a term yet. We could, but we're not. Okay, remember the square root, the root part is the denominator of our exponent. So roots are on the bottom. So the square goes on the bottom of our fraction, and the power goes on top. There, that looks more like a 3. Okay, now we have 2 powers. We're going to move those to the front. 5 log 10a minus 3/2 log base 10b. And we're finished with that one. All right, so these examples, we are going to go the opposite direction. And the last ones, we took care of the powers last. This time we're going to move the powers back, and we're going to do that first. So the 4 gets moved. The n term does not have a power, so we don't have to move that one. So we'll say log base 3 m to the 4th minus log base 3n. And then we'll combine these into 2. Well, we're subtracting these 2 powers. Subtracting exponents means that we first divided. And so that's how we need to think about this. All right, let's look at the next example. We have 3 terms. You're always going to start with the first term on top, and then you will, anytime you see an addition, such as this, that means you multiply. Anytime you see a subtraction, that means you're going to divide. So we'll have our single logarithm. We're going to start with our first term, first number, 6. We're going to multiply it by 5. Multiply because it's adding. And then we'll divide because we're subtracting. And this actually simplifies. So let's simplify this. So 30 over 2. And 30 over 2 is 15. And that's the answer for example 4. Now, example 5, we are going to be solving for x. And the clue to this first one, when we're solving for x, is we want a single logarithm on each side. So, single log each side. That means we're going to have to combine the right side. So we have log base 5x equals, and we're going to have to move that 3, make a power, log base 5 2 cubed plus log base 5 7. Now I'm going to go ahead and change my 2 cubed to an 8. And I'm just going to start with writing down the left. And this addition means that I multiply. So I'm going to multiply 8 and 7, like that. And what I can do now is, since I have matching logs and matching bases, that means the number is the same. So we are going to cancel the logs. Okay, so I'm going to cancel, cancel, and that leaves me with x is equal to 56, and that would be my answer. All right, last example, we're going to follow the same procedure we did with example 5. We're going to combine the multiple logs on the left side, and we're subtracting right here. So that means we're going to divide the x and the x minus 5. So log base a, x over x minus 5, log base a, 6. And what we're going to do, like we did the last time, since the logs match, cancel. So we'll write what's left equal to each other, and this we can actually solve. We can cross multiply this. So cross multiply, and we'll end up with x equals 6 times x minus 5. Distribute your 6 like so, and I'm going to add 30 to both sides and subtract x. And that gives me 30 equals 5x, and so x is equal to 6. And that's how you solve logarithmic equations.